So, if you are multiplying radicals, and we've done multiplying a little bit already, but here's a little bit of review. Multiplying radicals, I'm going to add the word mixed in there. Just to review, when you multiply radicals, you're going to multiply I'm going to say the coefficients or the numbers in front. And we're also going to multiply the radicals. We always then simplify as a mixed radical in lowest terms to end with. So for example, just a mini example here, if you had 4 root 3 times by 7 root 6. Technically, the 4 root 3 is 4 times root 3 times 7 times root 6. So the reason you're allowed to multiply, and I said the coefficients, which I'm going to underline that in purple, and then underline those numbers in purple so you can make the connection by what I'm trying to say there. Because sometimes using math words doesn't help explain what's happening. You actually have to see it. So I can multiply the 4 times the 7 together. That's going to give me 28. And then I can multiply the radicals, which I'll underline in orange. I've got a root 3 and a root 6. Root 3 times root 6 is root 18. So step 1, we're just going to multiply the numbers together, multiply the square roots together. But then we have to write our answer in lowest terms, which means we have to break down the root 18 if it's possible. Does root 18 divide by a perfect square? In other words, can I break up root 18 to be the square root of something times the square root of something where one of them is a perfect square? Yes. 18 is 9 times 2. And so this will give me 28 times by, well, 9 is 3, and then times by root 2. So 3 times 28 will give me 84 root 2 in the end. So that's what it means to multiply mixed radicals together. What do we have? We have a big group of them multiplied by another big group of them. So you're going to have to multiply the first ones, multiply the outside ones, the inside ones, and the last ones. So if I multiply my first ones, can you see that you would have a 4 times a 3? That will give you 12. A root 2 times a root 2. I'm just going to write that as root 4 right now. Some of you are going to get really good at the fact that, does it make sense that when you multiply a square root of 2 times a square root of 2, you're basically squaring it, which would get rid of the square root sign. It's just going to end up being 2. But I'll write it as square root of 4 right now, and we'll simplify it afterwards. Then the outside ones, I'd have 4 times a negative 1, negative 4, root 2 times root 5, root 10. The inside ones, 2 times 3 is plus 6, root 5 times root 2, root 10. And the last ones, 2 times a negative 1, negative 2, root 5 times root 5. And again, I'm going to write the square root of 25 right now, but you might have seen that that was supposed to be 5 already. Square root of 4 is 2. 2 times 12, that's 24. Can you see that these two are like radicals? So I have 6 of them minus 4 of them. I'm going to have 2 of them. And you're going to have to ask yourself, can you simplify the square root of 10? In other words, is there a perfect square that divides 10 nicely? No. So this one stays. And then square root of 25 is 5, so 2 times 5 would be 10. Now these are like terms, so they can be put together. And we get 14 plus 2 root 10. There is a lot of mental math that goes into these questions. So, and the mental math is not hard, but you really have to focus. Because as soon as you start thinking ahead, like, oh, I want to do this question next, or this is what I'll do after this, you're going to make a little mistake. And then when you check your answer at the end of the homework section, you're going to find out it's completely off. And you'll go, what did I do wrong? Probably something little. Okay, so we look at part B. Change the colors up here. I'm going to have to multiply these two together, these two together, these two together, and these two together. So for part B, 4 times 4, that would be 16. Root 2 times root 2, root 4. 4 times a negative 2 would be negative 8. Root 2 times root 3, root 6. 2 times 4 would be 8. Root 3 times root 2 would be root 6. And 2 times a negative 2, negative 4. And root 3 times root 3, root 9. Can you see that the middle ones are like terms? I can underline them in purple again. Those two are like radicals. And there's a minus 8 plus 8. That's going to go away completely. Square root of 4 is 2. 2 times 16, 32. Square root of 9 is 3. 3 times a negative 4, minus 12. If you recognized that part B was a difference of squares, you could have gone to this one squared minus this one squared faster. Okay? How do we recognize it's a difference of squares? Do you see that all the numbers are the same? 4 root 2, 4 root 2, 2 root 3, 2 root 3. 1 is plus, 1 is minus. Whenever that happens, doesn't matter what you start with. If I have a plus b times a minus b, that's what a difference of squares is. You will always have the middle cancel out, and you will always have the first one squared, which is 16 root 4, and minus the second one squared, which would have been 4 root 9. And then you can do it that much faster. So I want you to practice these right now, because this is good mental math. And do a couple. Check your answers at the end of the section to see if you're getting them right.